integration of sine squared and cos squared in this section now. Alright, so this requires a substitution but of a rearrangement of formula rather than a u equals in most cases. Alright, so we're going to use the results of cos, going to use the result, of cos 2x. Okay, because part of that formula has cos squared and sine squared in it. We're going to rearrange that so that we can use what we've learned in trig integration to be able to integrate that. So the first one, so we've got cos squared of x is dx, cos squared of x dx. So, cos 2x, do you remember your double angle result?
Cos x, cos y,
Oh, that's sine.
Sin x, cos y.
That's still sine.
Cos x, cos y, take
No.
away sin x.
That's cos, but not the double angle there.
Oh, double angle.
Yeah. Alright, cos squared x, take away sine squared.
That's it.
Okay, so we can obviously use that cos x, cos y, sine x, sine y to get that result. Okay, so from that, because I want cos squared, I'll need to keep that there. And then I'm going to use, remember how we had 3 results for the double angle cos? Right, so if I substitute 1 minus cos squared x, that's from sine squared plus cos squared is 1. Yep. Alright, so it's going to be cos squared x take away a negative cos squared x. Take away 1. So I want this as subject, so cos of 2x plus 1 is equal to 2 cos squared of x and a half cos 2x plus 1 is equal to cos squared x. Right, and we know how to integrate this, don't we? And we know how to integrate a constant. Right, so that's what we do. We've made that substitution and we put that into the integrand. Okay, so the integrand will become half the integral of cos of 2x plus 1. Now we don't have to make any substitution because we know how to integrate both those components. Alright, so what's the integral of cos 2x?
Negative sin.
When you differentiate sine, you get cos. But when you integrate cos, you get sine. Alright? So, sine stays the same. Divide by the constant in front of x. Yep. And what's the integral of 1 with respect to x?
Oh,
X. And don't forget constant integration. Alright, so just rearranging your formulas from the double angle result for cos. Put the correct variables in there. Alright, put that into the integrand and then integrate with that. Okay, now don't forget, of course, we can differentiate all this and we would get the same result. Okay, so we differentiate sine, we get cos, so it becomes a 2 sine 2x over 2. So we're left with 2 cos of 2x over 2. We can differentiate sine, and then we get differentiate x plus 1, and that's what's there. Okay, so you always could have a quick mental check of your answer by differentiating what you've integrated, and it should match what you've got before you've integrated. Alright, let's try sine squared of 2x. Alright, so we've got to be careful. So cos 2x is cos squared of x, take away sine squared of x. But in here we have sine squared of 2x. Okay, so I need to put the coefficient of 2 in both of these, here and here, and that means I need to also do a double in here. So it becomes cos 4 of x is cos squared 2x, take away sine squared 2x. Okay, so we set it all up. Now we want sine the subject. So 1 minus sine squared of 2x away sine squared 2x. Okay, you can remember the results or you have to derive them. Okay, so it's going to be 1 take away 2 sine squared of 2x. Alright, so I need to get this sine squared 2x to subject. Alright, so 2 sine squared 2x is going to be cos of 4x plus 1. Okay, so you can remember the result, but I don't tend to remember them. I'll just quickly derive them. Okay, that one way you're helping you remember your trig stuff as well. Extension trig. Alright, so the integrand become, okay, so we've got the constants, we'll move that out the very front, and it becomes cos of 4x plus 1. Okay, and that's very straightforward to integrate using our mathematics rules. Okay, so if you write everything in terms of cos, right, so we get the same sort of thing we're integrating, just change the sign. So what's the integral of cos 4x? So? So sine 4x divided by the derivative of 4x plus the integral of 1. And don't forget, you've got indefinite integral, you need to have the constant integration there. Okay, any question? Alright, so this one you do need to use the U substitution. Okay, so they need to make, if you need to make a substitution, they should give it you what you need to substitute. Alright, so using substitution U equals sine x. So differentiate. So when you differentiate the sign, you get cos. That, so cos x dx, all there, ready to go. That's the U equals sine x. So really, all I need to do is integrate U squared du. Because cos x dx gets replaced with du, and sine squared x gets replaced with U squared. Okay, so U cubed over 3 plus the constant integration. And whenever you make the substitution, you need to write it back in terms of the original variables. Okay. Okay. This is really like the function of the function. So we sine x to the power of 3 over 3 plus c. So you bring down the derivative when you differentiate. So you come to 3 sine squared x over 3 times the derivative, which is derivative of sine is cos. So it'll be sine squared x cos x. Alright, and that's what's in my original integrand there. Alright, so we can do a quick mental check to be able to confirm whether we have the right answer or if obviously you don't have the correct answer. Right, a couple of definite integrals now. Right, so there's a constant 2, but that's at the very front, so really all I need to put it is in front of the integrand. So we really just need to rearrange for sine squared of x. So cos of 2x is cos squared of x equals sine squared of x. Right, so mental substitution for cos squared of x will be 1 take away 2. Sorry, yep, 1 take away 2. No, sorry, 1 take away sine squared of x, and then you've got another negative sine squared of x. So it'll be 1 take away 2 sine squared of x. Okay, so sine squared of x is going to be half. Because I've moved this over to the left, I'm going to move that over to the right. 1 minus cos 2x. 1 minus, yep. I've made an error there. Yep, I did. Right, that should be half. Move that over. Yeah. 1 minus cos 4x. Yep, so I should have had that minus sign, not the plus sign there. Didn't pick up on it because I didn't differentiate and check my answer. The only one I didn't do, and that was the one that was wrong. Right. Okay, so we still got it in terms of x. Okay, so I don't need to change variables. I've just rearranged the formula, not made a u substitution. Right, so the integrand becomes the 2 constant out the front. Bring the half constant out the front as well. It's pi over 2 to 0 of 1 minus cos 2x dx. Alright, so we've got x take away. So when we differentiate cos, we get sine. Sorry, when we differentiate sine, we get cos. So when we integrate cos, we get sine. Okay, so the half and 2 cancels out the front. Alright, and doing a quick observation with the 0 substitution, because 0 and sine of 0 is 0. Okay? So, pi is what in degrees? So it's half your period. Where's that? What's that value? 0. Okay, so that's sort of, you can use the graph to help you. So 0 times half 0. We've got 0 at the right hand side, so you're just left with pi on 2. Now, this was just integrating. You're not asking anything in reference to area or anything like that. We're just going to leave it as it is. If this was negative, you'd leave it as it is. Alright? Only if you ask for area, you have to do something else from that. Right, so the region bounded by the curve y equals cos x, and the line x equals 0 and x is pi on 2 is rotated about the x-axis. We need to find the exact volume formed. Right, so what was the formula for volume? Good. Okay, so we've rotated about the x-axis, we need y squared the subject. Right, so we've got y is cos of x, so y squared is going to be cos squared of x. Okay, so cos 2x is cos squared of x, take away sine squared of x. Okay, so it's going to be 1 take 1 plus cos squared of x, will be 2 cos squared of x, take away 1, hang on, plus 1. No, it's take away 1. This is 1 take away cos squared, yep. So we take away 1. Okay, so Q cos squared is going to be cos 2x plus 1. Yep. Okay. So, pi over 2, when you bring the constant of a half out the front, integral from pi over 2 and 0 of a cos 2x plus 1 dx. Yep. So when you differentiate sine, you get cos. So when you integrate cos, you get sine over the coefficient of x. Alright, so we've got pi over 2 times 2, so we've got sine of pi. Okay, so sine of pi is 0. 0 plus pi on 2, take away. And again, I'm observing that I substitute 0 here and here. The overall result is going to be 0. Okay, so we're getting pi on 2 times pi on 2. So pi squared on 4 units cubed. Okay, any question? Last one. Integral of cos of x plus sine of x all squared. What are you going to do first?
Cos squared x plus sine squared x equals. Like, can you do that?
What are you doing?
Bring the squared in.
Yes, but what are you missing before you do that?
I can't do that. Oh, it doesn't have. Oh, it's just
What's the first process you need to do to integrate?
get rid of the squared.
Sorry?
Get rid of the squared.
How?
Bring it in.
Expand?
Expanding there.
Right. What's after that?
To sine x plus x.
Right. What's next?
To sine x plus x plus a equals. Is that cos squared of x? No. It's double.
It is a double angle?
It's a double.
Or what?
Sine.
Double angle result of sine. Okay, what about the rest of it?
That's the 1 take away sine squared. So
Do I need to go through all that bit?
is it double?
What's the rest of it? What does the rest of it read? Ignore the middle bit, what's the rest of it read?
Cos squared x sine is.
Cos squared of x plus sine squared of x.
Cos 2x.
Hey?
Cos of 2x.
No? That's the takeaway in between. What happened when there's addition. We've used this in for previous 4 examples.
2 cos.
No?
Cos. You go cos. Wait, hang on.
Sine squared plus cos squared is
So obvious, isn't it? squared?
Nope.
Sine 3x?
No.
2x plus 1. 2 cos x squared plus...
How did I know to make that substitution here?
Oh. Because cos squared equals 1 take away sine squared.
Yeah, so where'd that come from though? Originally came from that.
That.
So what's sine squared plus cos squared?
2 sine.
No.
That's... I remember that now.
Yeah, good. You won't ever forget again, I hope. I've only been using it in the previous 4 examples, haven't I? Okay, this one I don't have to make any more substitution because I've got sine of 2x, okay, not sine squared of x, plus 1. Okay, so when you differentiate sine you get cos, and when you integrate cos you get sine, so when you integrate sine you're going to get negative. Okay, and if you're really fancy about the negative sign at the front, just swap it around. It's embarrassing.
I know.